Hello dear children, in today's class we will be discussing the inclined projectile motion and the parameters related to the inclined projectile motion. In the previous classes we discussed about what is a projectile, what is a projectile motion and how can we say that projectile motion is a two-dimensional motion and a horizontal projectile motion and the components related to the horizontal projectile motion. So links will be given in the description. Just go through those videos to get the previous knowledge regarding the projectile motion. So as I said that in today's class especially we are going to focus on inclined projectile motion. So dear children, before going to start our discussion, let us recall a few important points regarding the projectile motion. So for this projectile motion, dear children, we will consider a few things. We can say that some limitations. So what are those? The first one is that the initial velocity of the projectile should not be very large and the height of the projectile also should not be very large and the range of the projectile also should not be very large. Otherwise, acceleration due to gravity changes. But throughout our discussion, G must remain constant. Okay, fine. And one more very important thing is that throughout our discussion, dear children, air friction is neglected. As air friction is neglected throughout the projectile motion on the projectile, I can say that only one force acts, that is force of gravity. Gravitational force only acts on the projectile, that too vertically downward direction. So this is very important. Okay, fine. Now let us start today's concept, that is what actually inclined projectile motion. For suppose this is, let us take here the horizontal. Okay, now so with this projectile is projectile like this, such as that it is making an angle theta and this projectile is thrown with initial velocity u such that it makes an angle theta with a horizontal. So this is actually our concept. But do you think that it will go along the straight line path? Obviously no. Obviously no. Why? Because continuously, what we can say, force of gravity, gravitational force acting on it, right? So we also discussed in the previous class that this projectile motion can be resolved into two simple motions and which are independent of each other, Look at here. So as this projectile is projected or thrown with an angle, or we can say initial velocity u, such that it is making an angle theta with the horizontal, and these can be resolved into two components. This means what here? Initial velocity of the projectile is resolved into two components. One is the ux, another one is the uy. So this ux only we can say it as a u cos theta, and the vertical component is u sin theta. So this is a horizontal component and is a vertical component. And dear children, we know that on the projectile only one force is acting, that is a force of gravity, that too vertically downward direction. But is there any force acting on the projectile horizontal direction? No. So there is no force acting on the projectile horizontally. Hence there is no acceleration. Dear children, here one important point we need to understand. What is that? It is all about the ux and uy. So ux is what here? U cos theta, and here is a u sin theta. And we know that in a horizontal direction there is no force acting there, so hence there is no acceleration. So hence ux always remains constant. So we don't have any problem with this. That's what horizontal motion we can call it uniform motion, right? Okay, fine. But this is very important to understand. Vertical component of the velocity. Why I am saying so? As this vertical component of the velocity, of course it is a upward direction, but force of gravity is downward direction, right? So which means what here? The magnitude of the vertical component of the velocity keeps on decreasing. Very important point. Which means what? Initially it has a maximum, let us say that, of course. So at this point let me just indicate. So here, okay, let me take one here, how it will get affected. Let me show you here. For suppose children, so this is, let us say its path. Okay, it's the initial one. So initially it has a ux here and here is a uy. Okay, no problem. When it reaches, see this line will indicate the magnitude of the velocity. Try to understand. So this is ux. So this is uy, and at this point it is ux and it is uy. So at this point ux and here is a uy, and at a maximum height it is ux only, okay now, but vy is 0. Vertical final means at a maximum height the vertical component of the velocity is 0, which means what? As the projectile is approaching the maximum height, the vertical component of the velocity, see, that's what here I have indicated the magnitude of the vertical component of the velocity with the arrow mark. See, this length of the arrow mark keeps on decreasing at the maximum height 0, which means what? The vertical component of the velocity at a maximum height is 0. Again after that of course at every point horizontal component will be same only, but here vertical component, look at here, vertical component will be like this, vertical component will be like this, vertical component like this, which means what? Here again vertical component of the velocity keeps on changing, vertical component of the velocity keeps on changing. This is a very important point to understand. Okay na? Fine. Projectile motion can be resolved into two simple motions, right? So first one is horizontal motion, and the second one is vertical motion. So here first the parameter which we are discussing is equation of trajectory. Children, what is the trajectory? The path along which a projectile is traveling is called trajectory. What is the equation of trajectory? During its motion, it covers some horizontal distance as well as some vertical distance. So the equation which gives a relation between the horizontal distance and the vertical distance covered by the projectile is called equation of trajectory. Okay, fine. Okay, let us come back to our discussion. So as I told you that here projectile motion can be resolved into two simple motions. One is the horizontal motion, another vertical motion. Children, in a horizontal motion the force acting will be 0, hence there is no acceleration. As there is no acceleration, obviously ux remains constant. So as the velocity remains constant, this motion only we can call it as a uniform motion. So horizontal motion is always uniform motion in the case of projectile. Whereas when it comes to vertical motion, children, yes, there is a force acting vertically downward direction, hence there will be a force, means force is not 0. As force is not 0, acceleration is not 0, hence uy is variable. Hence vertical motion of the projectile is called what? Non-uniform. It is a non-uniform motion. So simply the motion of a projectile can be what we can resolve into uniform motion and a non-uniform motion. Now let us try to concentrate on the horizontal motion. So in a horizontal direction, let us say that the distance traveled is, let's say x. Distance traveled is x, and here initial velocity is ux. Okay, let us say the time taken is t. So we know that distance is equal to velocity into, that is speed, into time. So x is equal to, so horizontal component is what here? U cos theta into t. So can we write this as a t is equal to x by u cos theta? Yes, we can write. Now let us make it as a equation 1. Now vertical motion, dear children, yes, we have this formula, right? S is equal to ut plus half at square. But here vertical direction, let us say that the distance, the height, the vertical height, let us say that this one, right? So from here to here, let us say it is a y. Okay na? Okay, and here u is equal to, that is the uy is equal to u sin theta, and ay is equal to minus g. Now substitute all these things in this equation. What do we get? Let me write here. So y is equal to u sin theta into t minus half g t square, equation 2. Dear children, now Let us see the equation 2. In this here t is there, right? So in the place of t, we are going to substitute x by u cos theta. I mean substitute equation 1 in a 2. So then what do we get? Look at here. Y is equal to u sin theta into, in the place of t we are writing x by u cos theta minus half g. So this whole square, right? That is x square by u square cos square theta. Let us simplify this. U cancel. Sin theta by cos theta is a tan theta. So here y is equal to tan theta into x minus g by 2u square cos square theta into x square. Are you able to see this equation, whatever I am writing? So no, you are not able to write. Okay, let me write here. So it is not seen. So okay, no problem. Okay, let me write here, children. So I am writing here. Try to understand. So here y is equal to, we got tan theta into x minus g by 2u square cos square theta into x square. So children, this is the final equation. This is what actually equation of trajectory in the case of what? Inclined projectile motion. And this is a quadratic equation in x, whereas linear in terms of y. And this is nothing but what is, children? So it is nothing but the equation seems to be ax minus bx square. So this is y is equal to ax minus bx square in this form, right? This is nothing but the equation of parabola. So hence we can say that the trajectory of the projectile is a parabola. So this is how we can prove mathematically. So this question can be asked in board exams also. Okay na? So prove that the trajectory of the projectile is a parabola, which means what? So mathematically you have to talk everything. Okay na? Just copy this and we'll calculate remaining factors, parameters. The second parameter is time of ascent. So second one is time of ascent. So children, what the time of ascent? So the time taken by the projectile to reach a maximum height. I mean the time taken by the projectile to reach O to A. O to A is called time of ascent. Means in a vertical direction it is moving. In a vertical direction to reach a maximum height, it takes some time. That time only we can call the time of ascent. So children, now in a vertical motion, so let us try to calculate. So at point A, at a maximum height, of course Vy is 0 and initial velocity in vertical direction is u sin theta and Ay is equal to minus g. So let us apply this formula. Vy is equal to uy plus ayt. That is simply v is equal to u plus at, but we are applying now vertically upward. Vertical motion we are applying. So substitute this. 0 is equal to u sin theta minus gt. So this can be written as gt is equal to u sin theta. So t is equal to u sin theta by g. So this is the time of ascent, that is time taken by the projectile to reach a maximum height. Okay, fine. Now the third parameter is time of flight. Capital T. So actually what a time of flight is, children? The time in which projectile remains in air is called time of flight. Means this is a point of projection. Theta is what actual angle of projection. From here when it is thrown, so it takes some time, right? I mean during this time it remains in air only. Till it reaches point B, it remains in air only. For this the time taken only, the total time taken to come back to the point of the same level of the projection is called actually time of flight. Children, as we are neglecting the air friction, the time taken from O to A is equal to the time taken to the A to B. So this time of ascent is O to A, time of descent is A to B. So you can add these two. So this is nothing but actually what here? U sin theta by G. So if you want the time of flight, so 2 times of time of ascent, so it is nothing but 2u sine theta by g. That's it. This is what actually. Of course, we have one more alternate method also. Let me tell you that. What is that alternate method? So alternate method also, we have alternate method. So what is that here? So s is equal to ut plus half at square. Okay, children, from O to A, what is the total displacement travel till here? A to O to A, finally the displacement is 0, right? Okay, 0. Okay, this is very important. This is very, very important. So of course, vertical direction I am talking. Vertical direction only, completely we are talking. So vertical direction, the displacement is 0. Vertical direction. So the vertical initial velocity is u sine theta into the time taken, total time taken is t minus half g t square. Now you can take your t as a common. T into u sine theta minus half g t is equal to 0. Okay na? So with this equation, two things are possible. One is t is equal to 0. So t is equal to 0 means what? Initially at the instant, the moment when it just about to project, about to throw, at that time actually the t is equal to 0. The time of flight will be what? At the initial point, at a point of projection, the time of flight is how much? 0 only, right? Okay, fine. Now second possibility is what here? U sine theta minus half gt is equal to 0. If you can simplify this, half gt is equal to u sine theta. So from this I can write t is equal to 2u sine theta by g. That's it. Again we got a same thing. So the time of flight is equal to 2u sine theta by g. 2u sine theta by g. See, I think my board is not adjusted. It's going down. Okay. So this again, see, look at here. From this only we can write it as a t is equal to 2u sine theta by g. That's it. This is what actually expression for time of flight. So it's the time of ascent and it is the time of flight. The time of flight is what actually the time of flight means what? The time in which the time in which the projectile remains in air is called time of flight. It is nothing but the double the time of ascent. You see, it is possible only when we neglect the air friction. Okay, fine. So this is what actually time of ascent and the total time taken to come back to the point of level of the projection. Is it fine? Okay. Now the fourth parameter is maximum height reached by the projectile. Maximum height. The fourth parameter is maximum height. Maximum height. Let us say the h. So that is maximum height is this one. This we have to calculate. Okay, maximum height reached with the projectile. Okay, so we know this, right? V square minus u square is equal to 2as. So now we are discussing for a vertical motion. Okay, so for a vertical motion, at point A, final vertical component will be 0. Vertical component velocity will be 0. And anyhow, uy initially it is a u sine theta, and ay is equal to minus g, and s, that is the displacement vertical direction, is a h. Okay, now substituting this will be 0 square minus, so u sine theta whole square, u square sine square theta is equal to minus 2gh. So this will be minus u square sine square theta is equal to minus 2gh. Minus cancel, get this 2g this side. So h is equal to u square sine square theta by 2g. So this is a maximum height reached by the projectile. Fine. Okay. The fifth parameter is what is the range of the projectile. So what is the range of the projectile, children? So the horizontal distance covered by the projectile. The horizontal distance covered by the projectile. Children, we know that in a horizontal motion, uniform motion. So horizontal distance nothing but what actually? Distance, horizontal distance only. So we know that distance is equal to speed into total time taken. Let us say capital T, total time taken. So this horizontal distance is x, nothing but we can take it as r. So okay, so here distance r is equal to, speed is what? Horizontal speed, horizontal component of the velocity, u cos theta into time of flight. How much we got? 2u sin theta by g, 2u sin theta by g. So children, here we can write a one expression like this. Look at here, this can be like this, 2 by g into u cos theta into u sin theta. Can we write? Yes. So this is nothing but the horizontal component, it is nothing but the vertical component. So we can write like this, range is equal to 2 into ux into uy by g. So it is also one expression only, one expression. If not, look at here, how can we write? U into u square. So r can be written as r is equal to u square, then 2 sin theta cos theta, okay, u square, sorry, it is 2 sin theta cos theta by g. But children, 2 sin theta cos theta is nothing but the sin 2 theta. Okay, so range can be written as u square sin 2 theta by g. So this is a range, this is a range. Of course, in exam they may ask a question, when the range can be maximum, when the range can be maximum, means for what value of the sine, for what angle of the sine value will be maximum. So 90 degrees. To have this total 90 degrees, children, theta must be 45. So if theta is equal to, if theta is a 45 degrees, then range will be maximum, that is u square by g. This is a maximum range, maximum range. So maximum range is how much, children, we got here? R is equal to u square by g. Okay, fine. And the last parameter is instantaneous velocity. What is the instantaneous velocity, children? So at any instant, the velocity of the projectile. See, initially it has two components. At a maximum height, the vertical component will be 0. Okay, but horizontal component will be same only. For suppose, let us take at this point, let us take that. So here at this point here, of course, horizontal component is always constant. Let us say the u cos theta, but the vertical component will be, let us say the vy, and the resultant velocity will be, let us say it's a v, such that it makes an angle alpha, let us say that. Then how to calculate this? So the resultant velocity can be calculated like ux square plus here vy square. Of course, we know that here ux is equal to u cos theta, ux is equal to u cos theta, but vy is equal to what? Vy is equal to uy plus ayt. Okay, so here vy is equal to, this will be u sin theta minus gt. So these two values, these two values should be substituted in this. Then v is equal to square root of ux square, means this whole square, that is u square cos square theta, plus, so this whole square means a minus b whole square, vy square means this whole square means a minus b whole square formula we have to apply. Of course, let me write u sin theta minus gt to the whole square. Okay, now let us simplify this. This is going to be u square cos square theta, a minus b whole square, a square plus b square minus 2g ut sin theta. Children, here u square cos square theta plus u square sin square theta. In this u square you can take as a common. When you take a u square as a common, sin square theta plus cos square theta, its value is 1, right? So hence this can be written as square root of u square plus g square t square minus 2 u g t sin theta. So this is a instantaneous velocity. But direction, alpha value, yes. So look at here, tan alpha is equal to, tan alpha, of course, look at here, So this is, so any vector can be shifted parallel to itself. So this is nothing but the Vy, okay, it is Vy by Ux, V by Y Ux, that is, so alpha is equal to tan inverse, Vy value is how much? U sin theta minus gt by Ux value is how much? U cos theta. So this is the direction of the instantaneous velocity. This is the magnitude and here is the direction. So dear children, so this is today's concept. So today we discussed about inclined projectile motion and the parameters related to it. So next class we are going to discuss the projectile motion on an inclined plane. Try to understand. See, there is a difference. It's an inclined projectile motion, but already one inclination will be there. From there we will be projecting. From there we will be throwing a projectile. So then how that projectile motion is going to be, and we also will discuss the parameters related to that projectile motion. Okay, children. Thank you so much. All the very best.